the potential benefits of AI in African higher education and the wider economic sectors. Just as with previous innovations, AI and other digital technologies cannot be ignored. There's anxiety about new technology in education, and this is not uncommon. Previous generations have worried about students using pocket calculators. They've also worried about students having free open internet via Google. My name is Nodumo Dlamini, and I work here at the AAU as the director responsible for ICT services, communications, and knowledge management. My role today is to be the Madam of Ceremonies. In terms of housekeeping issues, feel free to post your questions and comments in the chat. This is to those that have connected on, and we have 156 that have connected online. So they are most welcome. There's also interpretation in French. Those who need it, please choose the French channel. It therefore gives me great pleasure to introduce the Secretary General today, after which I would introduce our program. That are connecting online. I will actually be sharing a slide as I introduce Professor Olushola Bandele Oyewole. Professor Olushola Bandele Oyewole is the Secretary General of the Association of African Universities. Previously, he was the Vice Chancellor of the Federal University of Agriculture in Abeokuta, Nigeria. He is a professor of food science and technology. He's also the former president of the AAU. He has previously been a staff member of the AAU in his early life and has also been a staff member of the African Union Commission. Professor Olushola Oyewole has published several scholarly and peer-reviewed journal articles, book chapters, conference papers, and other technical papers. He holds a Bachelor of Science degree from Obafemi Awolowo University in Nigeria, a Master of Science from University of Ibadan, and a degree in food science and technology, also from the University of Ibadan. So please allow me to welcome Professor Oyewole to the podium.
Thank you very much, Madam Nodumo, the Director of ICT and Knowledge Management in AAU, Vice Chancellors, Presidents, Pro-Vice Chancellors, and other institution heads connected or gathered at this particular time, colleagues from various African higher education institutions, representatives from the development partner organizations, valued students, and distinguished panelists. Our moderator for today's forum, Dr. Victor Udumuyiwa. Staff of AU who are present here physically, and indeed students who are present physically in this auditorium, invited guests, distinguished participants, friends from the media, ladies and gentlemen, please, with all protocols duly observed, I want to warmly welcome you all to the Students' Forum, which we are hosting today as part of our annual African Universities Day celebration. Honorable guests, for us here at the Association of African Universities and for all of us as higher education institutions across Africa, the African Universities Day is a special period where we get to celebrate debate, or in this case, the establishment of the Association of African Universities some 56 years ago on November 12, 1967. Our celebration this year is on the theme Artificial Intelligence in African Higher Education. We decided to prioritize the holding of this forum because our students and indeed the youths are critical in shaping the future of Africa. So many projections have been made about developments in our population scene. And we found that as of today, the youths constitute a very large percentage of the population of Africa. We believe that the young people of Africa must be at the forefront of discussing emerging issues such as artificial intelligence, with a view to leading its adoption and its integration into various sectors of our economics. Ladies and gentlemen, the young people of today are the ones that will have to live and work in the emerging technology-driven world, and therefore we need to put them at the center of these new discussions. When we planned this Students' Forum for the African University Day, we are hoping to achieve a number of things, which include showcasing the AI-related innovations, research and usage by students and the youths. 2, addressing misconceptions and concerns around artificial intelligence. 3, creating a continental community of AI enthusiasts. 4, promoting the visibility of the work of our students and youths in the area of artificial intelligence. Ladies and gentlemen, artificial intelligence is already being used in universities and colleges, and these applications include chatbots, personalized learning platforms, and data analysts for student support. Our higher education institutions need to embrace artificial intelligence and know how to leverage it while addressing the concerns. Indeed, artificial intelligence could support improved student learning outcomes, enhance administrative efficiencies, and cost reduction. I'm aware of the challenges that so many people have expressed about artificial intelligence. People have talked about the integrity of using artificial intelligence in an educational environment, especially in a world now where if a teacher, a lecturer gives you an assignment, all you need to do is to go to chatbot and get the answers. And one will be wondering if the result you are presenting is from you or from somewhere else. We're in a world where people now write a whole thesis, PhD thesis, using some artificial intelligence forum. And therefore, there's a need for us in academics to design better ways of this, knowing the integrity of the reports submitted by our students. To me, the artificial intelligence can be an additional teacher to the students, giving you the opportunity to have a better ideas of the issues that you need to address. I believe that the challenges associated with artificial intelligence can be overcome. People have talked about data privacy, bias in algorithm, and job misplacement. For sure, there are other instruments with which these challenges can be overcome. As an association, we continue to be concerned about students who are affected by the digital divide and those displaced by conflicts. The research and innovation must also focus on addressing some of these challenges which I've mentioned. I would like to extend our profound gratitude and appreciation to all our member institutions, students, and stakeholders for your commitment to African higher education and for working closely with AAU over the years. Before I conclude, I want to especially welcome to AAU our new Director of Research, Professor Ama, who is attending this public forum for the very first time. We are looking forward to his contributing greatly to the work of AAU in the years ahead. I also want to seize this opportunity to extend my appreciation to the government of Nigeria for the special donation they've made to AAU this morning to support the work we are doing here. I want to thank you all, our honorable guests, students, distinguished ladies and gentlemen, for joining us to celebrate this year's Africa's University Day. I encourage us all to actively participate and contribute to the discussion. Thank you for your attention.
Thank you very much, Professor Olushola Bandele Oyewole, for your remarks. What I will now do, I will briefly take us through the program and then introduce Dr. Victor Odumuyiwa, who will be the moderator for the session today. So for the benefit of those that are online, I'll share my screen again. So what we would like to achieve today, we would like to have a students-led discussion forum, which will be moderated by Dr. Victor Odumuyiwa. And then after the students present, we will then have questions and answers. So we'll have a session where we engage with those presentations. So the panelist students are coming from the University of Lagos, Nigeria, Kwame Nkrumah University of Science and Technology in Ghana, Université Gaston Berger de St. Louis in Senegal, Strathmore University in Kenya. We will also have a recent MSc graduate, Mr. Ido Jamiu from the University College of London. I would now like to introduce Dr. Victor Odumuyiwa. He is a senior lecturer in computer science in the Department of the University of Lagos, UNILAG in short. He is the director of the Innovation Hub at UNILAG. He's a member of the Advisory Board of Data Science in Nigeria. He leads a research team focused on data science and natural language processing. Dr. Odumuyiwa is also a certified security intelligence analyst and application security analyst. He has served as a technical program committee member for various international conferences and workshops. He obtained his PhD in 2010 from Nancy II University in France. He's proficient in French, and he is a visiting faculty member to the World Bank funded Center of Excellence at the University of Benin, at the Institute of Mathematics and Physics. So Dr. Victor Odumuyiwa, you are most welcome. What then I think we will need from you is your opening remarks, and if you could tell us the order maybe in which the students will be presenting so that we can identify them on Zoom and also make them co-host so that they can share their screen. So over to you, Doc. Thank you very much. And once again, I welcome the 190 virtual attendees. Thank you.
Yeah, thank you so much, Madam Nodimo Delamini. Yeah, great to be here. I want to, I would say, permit me to stand on the existing protocol as laid by Professor Olusola Bamidele Oyewole, the Secretary General of AAU. And so I'll just say, good day, ladies and gentlemen. We will start by having presentations from the students from the different institutions. And then we have a session of question and answer. So what I would say is that as we start the presentation, just be writing your questions down, and you can also be typing them in the chat box. So that helps us to collate the questions. We may still give room also for people to ask their questions directly, but I think the more we can type, the more we can send in the chat box, the better to be able to manage our time. Yeah, so, well, talking about artificial intelligence, I think it's no longer something strange to every one of us. And really thanks to ChatGPT, because I mean, it was when we saw this application last year that many people believed and began to see that this technology is actually very useful and is going to actually take over and do a lot and apply, and it can be applied to different domains. So ChatGPT helped us to accelerate the acceptance of the technology. But AI has been on for the past 40, maybe 50 years. People have been doing research in AI. But just like the recent development is making it more easier for people to appreciate what AI can do and to see the direction we're going. And here in education, because also I'm representing the EduAI Hub here, which is an IDRC funded project, research project on enhancing education in sub-Saharan Africa using AI. So AI in education is also something very important, and the three pillars we've been looking at in that aspect: solving the problem of bias, the problem of language barrier. We know that it's a problem in sub-Saharan Africa because of our content in our official languages, and also the problem of inclusion and the problem of our education administration. But today we are focusing on the students' innovation. And we're going to be showcasing their innovation, what they've done. They're going to explain to us what they did and what they are doing. And we'll be asking questions and seeing how this can benefit. And also, maybe be able to also set an agenda going forward. What do we want to see the next 2, 3, 4, 5 years happening in our institutions regards to AI innovations and developments? So for today, we're going to start, I think we should start from the host university. We should start from the Rail Innovation Center, the team from NUS in Ghana, and then we'll move to the Unilag team. After that, the Strathmore team, then the Association for AI team from Senegal, and also we have Mr. Idowu Jamiu also to round up all the discussion, the presentation for us. So without wasting time, we can have the team from Ghana can we have the slides for the team, please? Projected.
Hello. I think I need the team from Ghana to identify themselves virtually. Professor Eric Chow, if you could assist us so that we make them co-host.
Okay. Good morning from the Rail Lab. Elton Modestos is online. He will be leading the presentation from KNUST. Elton Jabin Modestos.
Carson. So can we make Elton a co-host so he can share his slides?
Can we make Elton a co-host, please? Thank you.
So Halton, your team has about 12 minutes, 12 to 15 minutes to present. Yeah, so please go ahead. You have the floor.
All right. Thank you very much. Good morning. I'm Elton. This morning I'll be presenting on one of the active projects going on in Real and Tepa Lab, which is an Afrocentric palm oil adulteration learning model. Please, can I be heard?
Elton, please remember we are interpreting, so don't speak fast, please. Thank you.
All right. I'll go as slow as I can. Please, is this space fine?
Yes, Elton is fine.
All right. Yes, so as I said, I'm presenting on an Afrocentric palm oil adulteration learning model that is being worked on by Real and then Tepa Lab. Really, it's the overview of it and the first iteration of the work, actually. And so in this presentation, I'll be taking you through the background and then the problem statements, move on to the related works for the research, then how it shaped our objectives, and then the data set creation, and then the model itself, the first iteration of the model. Now, the background starts with these statistics that we have about Africa and Sub-Saharan Africa. Who published this, that Africa has the highest per capita incidences of foodborne illnesses, with about 91 million cases of acute illnesses, and then 137,000 deaths. Now, these statistics are very large. They are very significant. Now, the case is even worse when you look at another GFSP report that shows that the food safety researches that are going on in Africa, most of them focus on export markets because they are donor funded by the experts. And then at the same time, our food demand is projected to increase by 178% by 2050. And so it's really a big issue when it comes to food safety. And then we as Africans, we have to work on food safety problems that we have. And then one such problem is the adulteration of palm oil. Now, palm oil adulteration occurs quite across West Africa and Sub-Saharan Africa. It's a very popular incident, very popular in Ghana, in Nigeria as well. Usually people adulterate it with azo dyes. These azo dyes are carcinogenic. These azo dyes are
Healthy, you are muted. Oh, yes, thank you.
Yeah, the the motive is to increase the consumer perception of their products. Palm oil in general is cheap, all right, but consumers usually look for some certain color and texture in palm oil, and then because of that, the market women and even the actors in the supply chain along the supply chain find themselves spiking these palm oil with doses of these adulterants. And then the determination techniques usually by expert judgment and then laboratory analysis. Now, when we look at the laboratory analysis, they could be classified in under various umbrellas. We have the spectroscopy, the chromatography, the imaging techniques, fiber optics, DNA-based analysis. Now, when you look in literature, we have a lot of proposed work that centers around this. Like they all revolve around these laboratory techniques. Now, but these laboratory techniques, one, they require the laboratory expertise. That's one. They come at a convenience of time, and then they require extra cost if you have to use it in the market scene. As in, if I'm a consumer and I'm going to buy a product, if I have to take samples of the palm oil I'm buying and send it to a lab for it to be tested, that can take days, and then I have to pay for it and then come back and come and buy. It's not really practical to be used in our market scenes. And so there is a need for an automated and portable approach. Now, and so that was the objective for this research. We started with getting an automated and portable approach that does not require laboratory expertise. Now, when we get to stuff that does not require laboratory expertise, then it's a tricky issue there because most of them are subjective. They testing it to determine the color. Scientifically, there is no objective way of doing it without the chemical laboratory processes. And so, but then we know in AI that it is possible to have learned representations. It's been proven by theory. One 2018, the famous Kaiman He paper on ResNet, residual networks, and even the seminal paper on deep learning by the godfathers of deep learning also. It's possible that we can learn hierarchical data representations of raw data. And so it's been used over and over and over. And CNNs have been used when it comes to image recognition and then computer vision. And so that was the end goal because it's not possible to get a scientifically objective way of doing it without the laboratory expertise. Rather than trying to hand engineer features, you feed the images to the deep learning model, and then it will learn these hierarchical representations so that when you deploy on the market, anything that deviates substantially from these learned representations of this palm oil can be flagged as impure. So that's the overall hypothesis there. And then because of that, we started with creating an Afrocentric data set for the palm oil adulteration and then creating these models. Now, a data set creation, we were informed by some of these decisions. Some key insights we got from our research is that the maturity level of the fresh they really affected the color of the palm oil in terms of they give the carotenoids level, and then because of that, whether it's matured or ripe or rotten, depending on how they are used, the color of and the quality of the palm oil is affected. Now, the extraction procedure, being it mechanized or local way, also affects it. And then the storage conditions, they affect the free fatty acids, the pH, the moisture, and the carotenoids. They degenerate over time. And so these affect it. exposure to UV, exposure to heat. And so we had to simulate all of these in our experimentation design for us to capture data sets that will be very representative of what we get at the marketplace. And then the camera consideration, we had to make sure we got budgeted phones that are low on camera, and then the different times of the days when palm oil could be bought at the market to we had to simulate all this into our experiments to get a representative data sets. And so that's the overview of the flowchart. The intuition here is to take a sample through all of the process, all of the conditions we described earlier here. Yeah. So that was the intuition, and then after that we subjected to these camera capture conditions. And then that's all. Now, when it got to the model creation, we set up with some hyperparameter tuning. It really wasn't, it would have been a very exhaustive work, it would have taken much time consuming to try all the available architectures that we could use, try everything, train them on the full data sets to be very computationally expensive. And so we had to use a hyperparameter tuning to decide on which set of layers, which set of hyperparameters that we could use for these foundation model we were building. And so we use weighting biases sweeps. And then this one, as you can see here, showed the least loss. It used a stochastic gradient descent as the optimizer. We were using a Bayes optimization search model. And so how Bayes optimization search model works is it's a probabilistic approach. And so it hones in the hyperparameter search space, the ones that are doing well. We realized that it chose more of the Adam initially, but after the SG, this stochastic gradient distance was proven to be better. It was doing more of that. And then it cuts across the other hyperparameters we considered, like the number of convolutionary layers, number of fully connected layers, the number of epochs to train, the learning rates, and even the batch size. And so it did that, and then it presented us with the best performing model. If we use a stochastic gradient descent SDG, and then it sets the learning rate to 0.018 with 3 fully connected layers, 6 or more epochs, and 3 convolutionary layers with batch size of 64, then we're getting optimal performance. And so we build a model with such hyperparameters. And then that's the first iteration of the experiment. We built the model with this, and then these are the results. We have a loss reducing drastically, almost getting to 0. And that's the training loss. It translates to the validation loss as well. It also decreases. It's the same performance. It's the same characteristic. And then it translates to validation accuracy as well. We have very close performance.
Yeah, about
almost
1 or 2 minutes more.
Yeah, I'm almost done.
Okay.
Yeah, and so it's performing very well, well above 90 in terms of accuracy for all of them. And then we see some of the prediction results when we print. It's very confident, the ones that it got right, and it got them right. These are the probabilities at the end of the soft mass layer, the ending layer that it presented. It's predicted these with very high levels of accuracy in there. And so almost all of them were right. And that's it for my presentation. I'll be happy to take any questions later.
Yeah, thank you, Helsin. Thank you for the presentation. You presented on the AfroPalm project, what you did using deep learning to detect the palm oil, look at palm oil images. But before I move to the next presenter, I still, because the population here, not everybody here is an AI person. So just like in 2-3 sentences, just summarize what you presented to a layman so they understand what you are doing in just 2-3 sentences, then move to the next person. So that can help them to be able to ask right questions from you later on.
Right. So, in summarizing one sentence, the whole goal is here. Because we don't have an objective way of because we don't have an objective way of determining palm oil adulteration. We are using AI to learn the representation, to learn how correct palm oil should look like, and then when we get any other oil that it's not what it has learned, it can flag it as possibly adulterated, and then it will be released as APIs so that smartphones can scan it using cameras, so that at the market anyone can take their phone, scan the palm oil they have, and then it will tell it, oh, high chances of adulteration. Go to the lab, go and check it out.
Thank you so much, Elton. So Elton has told us of the innovation, how to help us to buy the correct palm oil. So when you get to the market, you don't want to buy adulterated palm oil. You don't want something that will be dangerous to your health. And so they developed a model that can help using deep learning to help to know when you scan an image, tell you an image of palm oil to tell you whether it's adulterated or not. Yeah, so we'll be happy to see the API released and to see the application on the smartphones so that we can start using it. Thank you so much, Elton. So we're going to move to the next presenter, to the Unilag team. I think the presenter, there are two presenters. So we have Fortune, and also we also have Fagore Oroyayomde. So the two of them can be made co-hosts so that they can go ahead with their presentation. Fortune Adekogbe and Fagore Oroyayomde. So host, can you please make them very good? So Fortune, then Fagore Oroyayomde, you can make into a co-host. So Fortune and Ayomide, you have the next 12 minutes to make your presentation. So just tell us your name again and where you're from, and you can start the presentation. I think you can share your screen now. Yeah, please go ahead.
Great, thank you, sir. I'm immediately sharing the screen and then we introduce ourselves.
You've been made a host, so you can share your screen.
Emily, can you unmute yourself and share the screen? Okay, I think I would share this on my end since we can't reach Emily yet. Well, Emily, if you can hear us, you are currently muted and we cannot see your screen. Okay, can we all see my screen?
Yes, can go ahead. Fortune can see your screen.
All right, great. I am Adikogbe Fortune, representing University of Lagos alongside Fagori Ayobide. I'm a machine learning engineer with a process engineering background. And Ayobide is a research assistant at NITHub. So our plan today was to share 3 projects we've been working on. But since I can't get to Ayobide at the moment, I will handle the discussion. Oh, Ayobide, can you hear us now? Or can you speak now? I can see him unmuted. Yes, okay, great. Okay.
So
So
sorry.
I'll handle the slide since I already have it up, and then we can just fire on.
Good morning, everyone. My name is Ayomide. Okay, can move to the next slide. Thank you. Can move to the next slide. Fortune.
Fortune, next slide.
Can you see my screen?
Yes, yes.
Yeah, so next slide. We're still seeing the first slide. Same thing.
Sorry, I'm in presentation mode, so it's not thinking.
Okay, so first off, I'm going to talk about DG Health. So DG Health is an AI for breast cancer. So introduction, such as we know, breast cancer is like the most diagnosed type of cancer in the world. Here in Nigeria, next slide, let's move to next slide. Here in Nigeria, we have like a lot of cases in breast cancer, and so there is a need for we to be able to diagnose breast cancer early. For an example, currently have a friend that is running a chemotherapy. Now, at first, she didn't know she had breast cancer because she just felt like there was a lump on her breast, and then he thought, so medical practitioners thought it was a boy. But currently she's on cancer stage 2, and they could not diagnose it early enough. So we thought of a need for we to diagnose cancer early. So breast cancer makes about 22% of the total number of new cancer cases in Nigeria. So we have different cancers. There's breast cancer, there's prostate cancer, cancer of the eye, thereabout, but breast cancer top the charts. Next slide, next slide. So our solution is an application that first of all manage patient records and also has an external feature by diagnosing breast cancer. Next slide. So the whole process is, first of all, we got data sets from Cargo. So just a good prototype data set from Cargo that has mammograms, images of mammograms, and then we use a CNN model to train our data and also test the performance of our model. After performance, we got an accuracy of 95%, which is quite good, which is like really, really good. So the aim of this project is that getting data. I think one challenge we got about data is accessibility to data in Nigeria. Me and my team, we went to Roots Cancer Health at Roots, and then the whole process of getting data was long. We had to get a form, but then I think it's not easy getting data. I think that's why we resorted to using data set from Cargo, and and it performed really well. So we hope that at the end of probably getting like a data set from the Roots would at least have like a good model for outside use. So you can move on, just move on. So the next slide will just show the demo. So you can this slide is a video. You can just play it. Yeah, thank you. So DG Health here. The doctor. Imagine me as the doctor. I'm signing in. So on my page, I can see total number of patients, and then I can diagnose patients. Two methods. I get metrics which the radiologists have done. So they measure like different things, probably the length of the tumor, the width of the tumor, the mean average. So from different radiologies, and after then, prediction is made. Also, this data was also got from Cargo. So most of the data we used for this project was got from Cargo. So this is like the first stage of, if the doctor does not have like a mammogram, then he can use this information to predict. So it's just giving it values and diagnoses it. So yeah, we can move to the second one, which uses mammogram. So you just need a picture of your mammogram, and then yeah, this is the picture of the mammogram, and then getting your results. Yeah, so we show the diagnosing with a percentage confidence, and that was all about this app. Nothing too fancy. We just wanted something that can manage patient record and can also test for early detection of cancer and relax. So I move to Fortune, present the other projects that we have. So Fortune, over to you.
All right. Thank you very much. Okay. Let me share my screen.
Fortune, we can see your screen.
Okay, hold on. Can you see my screen again?
Not yet. No. Yes, fine. It's okay now. So please go ahead. You have just about 5 minutes left. Yeah.
Okay. Can you see the current screen?
So I still saying breast cancer on the screen. So maybe we should move to the next slide.
Hold on. I want to interrupt the share and share again. Okay. So the next project is on language translation, and it's named which is a phrase typically used by Nigerians when they don't understand what you're saying. And it is a bi-directional language translator that translates between English and the Nigerian Pidgin language. The reason why we decided to take on this project was because we understand that digital communication is very important in the world of today, and individuals that don't have access to the digital world and cannot communicate with other people in the language of their preference will be limited in, the scope of what they can achieve and how they can utilize the resources we have on the internet today. And to solve this problem, we at the NeetHub AI team built a transformer-based model to translate from English to Nigerian Pidgin and vice versa. To, set the stage for understanding why we decided to solve this problem. During our research, we found out that, though Nigeria has a wealth of languages, right? A lot of them, or a good number of them, are not recognized online or in digital world. Popular language translation services include languages like Yoruba, Igbo, and Hausa, which are relatively major languages. but they do include all the other, Nigerian languages. And it turns out that Nigerian Pidgin, according to a survey carried out by Statista in 2021, is the fourth most spoken language by Nigerian. And it's interesting that we don't have a lot of research contribution to such a widely spoken language. So we took on this project to, open the ground into exploring low resource languages, which just means languages that don't have a lot of data. So we took on this project to explore these languages that have not been typically covered before, as a way to, encourage others to do the same with other languages, and even, for Pidgin with other variations of the Pidgin language. Our solution includes first, included the aggregation of a data set of over 94,000 parallel sentences, because, like I mentioned before, this is a low resource language, and that means that we do not have a lot of data for Nigerian Pidgin on the internet, and in fact, previously existing data were removed because those that released them decided not to make them public anymore. So for this project, we had to aggregate the data ourselves by identifying data sources and then scraping data from these various sources, validating them, and then putting them into a database. After that, we experimented and concluded on a transformer model that translates from English to Nigerian Pidgin and vice versa. After we built these models, we built two versions of the system. But at the moment, we have deployed a web application via which we can, translate sentences from English to Pidgin to demonstrate the effectiveness of these models. The interface is something like this, and can be accessed by anyone. If you can put the link in the chat, that would be great, because I don't think we'll have time to go there and go to Chrome and explore it. But this is a sample prediction where you can see the English sentence and then the Nigerian Pidgin translation, and it does pretty well because it gets the it tries to it reduces the words into the phonemes, which is what you expect when you're listening to Pidgin and when you're writing Pidgin. I think the third translation is probably the one I agree with the most in this case. But yeah, this is the web app demo. And it's interesting because you can also go there and explore. Of course, models are limited in the sense that if you put in words that are specific to domains like scientific domains or specialized areas, it might not get them because they are not in the vocabulary to understand. But the hope is that with something like this as a base model, people in specialized areas can come up with even smaller data sets and just fine-tune the model that we built here and take it one step further to work in the different domains. And the last project we're presenting is on data interpretation for microscopy in battery research.
Because of time, you try to summarize this so that I can move to the next speaker. So just try to summarize of time.
Yeah, we'll do that. So the core of this project is centered around the fact that during battery research, researchers try to improve performance of cycled lithium metal anodes by analyzing something called the solid electrolyte interface. But the process of analyzing this interface is very tedious and takes a lot of time. So in this work, I collaborated with a PhD student at the University of Chicago to build a machine learning model that accelerates and simplifies this process. The solid electrolyte interface in particular is essentially a layer that is created when your battery, so imagine batteries in your phone, laptops, and whatever, right? This interface is created when the lithium reacts, meaning when the battery is in operation. It helps to prevent further reactions on the anode, but it also limits your battery capacity. And so we decided to solve this problem using semantic segmentation. Our solution was to build a semantic segmentation model using the UNet and UNet architecture to solve this problem. And we also used something called the sliding window approach to improve performance by focusing on various areas of the image as opposed to processing the image as a whole. And a demo of the application is shown on this picture. For this particular application, we created a desktop application because we expect that researchers that have these images, first off, they get these images by experiments and they may not want to share it over the internet. So a desktop app is most ideal. And of course, the sizes of these images are very large. So the idea is if you have your images in a folder on your laptop and you start this application, you can easily run the processing and then generate the segmentation results, which helps these researchers speed up the process of understanding these images.
Thank you so much, Fortune. Yeah. So before I leave you before we move to the next speaker, we'll start the presentation. One is about breast cancer, kind of early detection, whether from some measurement or from mammogram images. And the other one is on language translation from Pidgin to English and English to Pidgin. So the last one is about battery, but to a layman, it's still more of research. So to a layman, what do you think, or what would be the application of the last one to a layman, somebody using a smartphone? So just quickly give us one, then we'll move to the next speaker.
So the first thing is the layman does not directly use the last application. The target users are researchers that are working on battery research and trying to understand the solid electrolyte interface. So the application works for people that are generally trying to work with microscopy images, but currently is configured for battery research. So the layman would directly not use this application, but of course they will be impacted by the results of the research that our target users, which are the other researchers, the result of the research that they carry out when we've accelerated the process. So what we're trying to do, we're trying to accelerate the process of research by picking a section of the whole cycle and then optimizing it for speed and making it easier for those researchers to iterate and then create better batteries.
Okay. So the goal is to create better batteries. So that's fine. Thank you so much. So I know that somebody's raising his hand, but we're going to ask questions generally later. We want to give room to other speakers to speak, to present. So Dureza, we'll come back to you. But all the same, you can type your question and put in chat box. And I will suggest that all speakers to look at the chat box for questions that are directed to them. I've been jotting down some. We can also be checking so that you prepare your answers and make it brief when you are going to answer. So Dureza, you can type your question, or you can wait till when we allow you to kind of open your mic and ask a question directly. So we will go to the next speaker. We'll go to Strathmore University from Kenya. Can we have the Strathmore team? So I think for the Strathmore team, we're having Maria Ogamba and John Muinde. So can we make them co-host, please? Maria Ogamba and John Muinde. So Maria, you've made a co-host, so you can go ahead and share your screen and start your presentation. And I think I will advise the control room, the media people, to also make the other speakers, that's the team from Senegal and Mr. Edo from UK, to make them co-host, so that when it's their time to present, we don't need to announce again, they just start presentation immediately. Thank you. So Maria, you can go ahead, please. Yeah.
Thank you very much. Hello, everyone. My name is Maria Ogamba. I'm a business intelligence analyst at iLab Africa and a Master of Science, Data Science and Analytics 'analytics' student, also from Strathmore University. So today I will be presenting on Wellness Buddy, which is an AI chatbot for mental health support for mainly focusing on university students in Kenya. So mental health is a major concern in Kenya, where a WHO report ranked Kenya fifth out of the African countries with a high number of cases of depression, which is approximately 2 million people. And these cases are rising among the youth. Unfortunately, mental health services are not accessible to many people. So there's still ongoing research to find out if you can utilize computer software such as chatbots to provide support. So integrative psychological AI has emerged as a scalable solution to meet the increasing demand for accessible mental health support. So for the methodology in creation of our model and our application, the model we used deep learning neural networks that was trained on a data set that we derived from basic mental health conversations that used cognitive-based therapy, that is CBT, and general advice from mental health professionals for depression and anxiety. This data set was created by combining data from different web sources on mental health advice from licensed professionals. Combining deep learning with transfer learning will enable us to expand the capacity of the chatbot when we increase the data size to improve the model in future iterations of the application. The chatbot will be able to leverage pre-existing knowledge from the original dataset to learn the new datasets that we'll incorporate. When running the model, we realized that it was overfitting, but we managed to use this using L2 regularization. Comparing the ordinary model versus the L2 optimized model, and also we tried out dropouts. We realized that L2 was the best and gave us the best accuracy as well. So in the next slide, I will demonstrate just a brief overview of how the chatbot looks like. So we integrated a model into a React Native front end. This application just has a very simple user interface where the user can interact with the chatbot and also be able to get access to more information on mental health care. So that's just a brief overview of how the application looks like. So for future development, we would like to work with mental health professionals to ensure the application handles the sensitivities and subtleties associated with offering guidance on mental health, wellness, and issues. Expanding the dataset to incorporate other mental health concerns can also improve the user's experience and the advice given to them. And finally, the application should comply with the Data Protection Act, particularly the privacy concerns, before conducting user testing and eventually delivering it to the market. So that is all from my presentation. Thank you for your time. I'd like to invite my colleague to do that presentation.
Yeah, thank you, Maria. So I think we have the second presenter. I should be made a host. John, sorry, I think it's John.
Yes, I am here. I think we also have another presenter from our team who should go before me, then I'll go later. That's Henry.
Okay. What's the name of this?
Henry Cello.
Okay, Henry. So to manage time, if the presentation are not connected, you can go ahead. Then it comes after you to manage time. If the presentations are not connected, if you can do it independent of his own.
Okay, just a minute then. Let me get this up.
So while you are setting up,
Hey,
there are several questions
yes.
and interactions going on in the chat box. So I think also some speakers have been responding. So it would be good if you can respond to some of the questions asked on the chat box, and later on we can summarize them. Yeah, please go ahead, John.
Okay, thank you. I hope my screen is visible to everyone.
Yes, we can see your screen. Thank you.
Okay, so I am John Muinde, and I'm a data scientist from Strathmore University. And I currently work as a data scientist with the World Data Lab as part of their data science team. And today I'll be presenting on the application of data science and machine learning techniques for improved farming of the black soldier fly larvae. So for this particular presentation, I'll first start off with the problem background, then go to a little bit of discussion on what this BSF is to those who have not maybe come across the term. Then we look at the methodological approach, then the results, and we wrap it up with the conclusions and recommendation. So this
So John, I also
understanding.
advise that you make like 5 minutes max and
Yes,
majorly
yes, sir.
focus on the impact of of your solution. Yeah, right, please.
Okay, thank you. So our main inspiration behind this project is trying to contribute to the fight against food insecurity, which is a major challenge globally and particularly in our continent. So approximately around 2.5 billion people live in this moderate and severe food insecurity. Globally, that comes to around 8.5 billion, and the projected population growth by 2020 is estimated to be around 8.5 billion. Then for a continent, that will be around 1.7. And with data from just 2021 alone, the food consumption demand was around 2.5 metric tons. So what does this imply to us in relation to the challenge of food security and going on? So with the growing population, we expect an increased demand for food. And also, as a result of that, there's a need to try and come up with solutions that are sustainable and climate friendly in the long term in terms of food provision. So one possible alternative that most researchers have been looking at is insect farming on a large scale perspective, and using these insects as a source of feed and food for both humans and animals. And that one particular insect that continues to show promising results is the black soldier fly larvae, which on the far left here, you can see the full grown black soldier fly larvae that has a life cycle of approximately 21 days. And the advantage of this particular insect is it consumes almost any kind of organic waste and easily turns that to frass, which can also be used as an organic fertilizer in farming. So apart from just addressing the challenge of food security, this insect you also able to address potential issues arising from climate change and waste management. Then on the right, we have a full-grown black soldier fly larvae. So this is what most farmers are interested in, up to rearing the insect up to this stage. This takes about 0 to 15 days to get to this stage. Once you are at this stage, you can harvest and feed them directly to animals, so or mix them with other feed contents. And the one advantages of these larvae being that they are highly rich in protein. So once you feed them to your animals, you are getting better output at the end of the day. So just this is a snapshot of the methodology that we are using. We wanted to work with real life data. So we set up an experiment in collaboration with the CIPE and Synergy in Kenya, who are doing this rearing at a large scale. So from 1 to 13, we have our predictor variables. The 14 was our target variable. Then the usual data processing techniques to prepare this data for analysis and to see what insights we are able to generate from these. Then this is the model training approach that we used, 70 for training, validation 20, and then test percentage 10. And because there's no need of having a project that that is not able to be used by the end user, we had to think up of an approach of how to deploy this particular model. So what you're seeing on the right is just a structure of the pipeline that we developed as a part of the deployment process. So these are our machine learning results because we didn't want to limit ourselves to just one particular model. We chose to train a total of about 8 models and compare them based on their evaluation metrics. So this being a regression problem, you can see the evaluation metrics we used there, RMSE, MAE, the MAP and R squared, adjusted R squared. So for this particular, you are looking for lower scores of RMSE, MAE, and mean absolute percentages. Then for the R squared and the adjusted R squared, you're looking with the model with the highest scores. So for that case, our best performing model was the random forest regressor. And then on the right side of it, we have now the developed solution system, which can be used by this particular farmer to monitor their production process and also predict expected output at the end of the rearing process. So I don't know if we have time, I'll just do a simple demonstration of how this works. Just a minute. Are you able to see what's up on the screen? Hello?
We can see your results screen. Were you trying to play a video? What were you trying to do?
Oh, I was trying to display something different. Okay, let me do this. Just a minute. Yes.
So we're running out of time, so be fast with it.
Yeah,
And
yeah,
the
yeah.
top
So,
what do you call the name of
so
the top
this is
presenter?
So this is our developed, like the dashboard, first of all, which the farmer uses to monitor their production resources. So they can do this for any month or whatever data they are coming in with, they can see what is happening at their farm. Then at this side, they're able to come here and say maybe the prediction period, just key in whatever data set they are having in their farm and see what, for example, what will they be the expected output of the end of the rearing cycles, and does that meet the market demand? And if not, how can they try to improve their rearing process to get improved production? So for this case, he will be expecting around 17.5 kgs per meter squared. So they can calculate that based on their number of beds and the total area to estimate their output at the end of their production cycle. Thank you.
Thank you so much. So does the platform give a recommendation on what to do to increase the production? I can see that it's telling them what it's going to produce, but does it handle the recommendation to push the boundaries?
Yes, we did that, and we have a score of like how we tune these parameters to get maximum output at the end of the day. I just could not fit everything here. For example, you are looking at let's say a bed length of 20 centimeters, because these particular insects like to burrow deep inside the food. So with a specific feed depth, you expect much more or a maximum output compared maybe to shallow feed depth. And then in terms of, let's say, the bed length, you want to make sure the number of larvae that are going here it does not impact the competition for resources within that area bed, so that you, at the end of the day, you are getting output that is good enough for selling and can make money for the farmers. So we have all that, and the system is already in use in the partner farm, that is Synergy.
Yeah, that's great. So it's already been used. That's fine. Okay, so we'll come back to that. Who is the top presenter from your group? What do you call the
That
name
should
again?
be Henry Chalo.
So Henry, are you okay? So please try to make it as brief as possible. You may not go in depth into the technology, but explain what the problem and the solution, so that we can move to another team, please. Henry, go ahead.
Oh,
Just a minute, I'm trying to get my slides for presentation.
Like I said earlier, so other presenters have made a presentation. Check the chat box. You see a lot of questions going on and also people dropping their contacts. So I think it's fine to respond to some of these questions there and also see people that are trying to connect with you.
Great. So my name is Henry Chalo. I work as a data scientist at the International Center for Insect Physiology and Ecology here in Kenya. I am an MSc graduate of a Master of Science in Data Science and Analytics from Strathmore University. I'll be presenting a project on a decision support system to improve the farming of edible crickets as a source of food for humans. And so the global population is estimated to approach 10 billion people by the year 2050. And the demand for food is estimated to increase by 50%. And so FAO approximates that by the year 2030, 653 million people will be undernourished and will be suffering from micronutrient deficiency. And for that case, the African population will bear the highest burden. And so the current source of food are becoming unsustainable due to the negative effects of climate change on arable land and water. And therefore, this calls for introduction of resilient farming practices, which includes introduction of new seeds of breeds, intercropping, nature-based solutions, and farming of insects for food and feed, such as the crickets. And so why am I interested in the cricket farming? Number one, the cricket farming, crickets are highly nutritious. We are able to minimize the greenhouse gases, which are commonly with the other farming practices, such as livestock farming. It requires less work, and there's also less land and feed and water which is required. And so many insects produce sounds to signify certain behaviors or activities which can be modeled to develop a decision support system to improve the cricket farming. And so using those sounds and the environmental factors such as temperature and humidity, we were able to come up with a system which can be able to help farmers to make decisions in terms of their rearing areas to improve the productivity of their farms. The methodology which I employed was data collection by setting up experiments in the lab in conjunction with the CIPE, where we collected audio and video footages of crickets. Then using IoT devices, we were able to collect temperature and humidity at the same time. We also did data pre-processing, which included the data labeling, feature extraction, class balancing, and such. So the machine learning models that were employed were random forest, SVM, and KNN. And then finally, we developed a web-based application that displays to farmers the status of their cricket farms, which also includes a notification system when certain parameters are exceeded. And so for the results, out of the three classifiers which were trained, random forest was the best classifier, which was deployed for use by the farmers. So what you can see on my screen is the temperature and humidity, where we were able to come up with some decision rules, because using the machine learning, we were able to identify the optimum temperatures and humidity under which we can optimize cricket growth. And so when you look at the temperature graph, which is displayed, when the pointer is on the red, it means that the temperature have exceeded the set limit. When it is on the blue side, it is also on the lower side limit of the temperatures. When it's on the green side, you are set. And so any temperature and humidity which is outside the certain range which is defined, then you are likely to get a notification via your email or via text message, which triggers action by the farmer. Now, in terms of the songs, the different call types produced by crickets include the calling, mating, and aggression. Calling and mating means that the crickets are healthy. Aggression means that the crickets are in distress. And so you can scan the web application, the QR code below to be able to interact with the system. And then finally, for the conclusion and recommendation, machine learning can be used to improve farming as human food and elevate food insecurity. We also anticipate to collect more data to merge with the existing sound and weather variables data to optimize cricket farming. And finally is to design IoT devices that can automatically regulate the temperature and humidity in the rearing room without the farmer's input. Thank you.
Yeah, thank you, Harry, for your presentation. You talked about how to cricket farming and using machine learning to enhance production. So because of time, I'm going to call the presenters from Senegal. Do we have them available? Are they online?
Oui, bonjour.
Bonjour.
Ok, je m'appelle Ousmane Diom, donc je représente l'Université Gaston Berger.
Ok.
Je puisse m'exprimer en français?
Oh, oui, c'est bien. Je pense qu'il y a des interprètes.
Ok, est-ce que vous voyez bien mon écran?
Oui. Bon, ça arrive. Attends. Pas encore.
Ok. Donc, je vais laisser Chimango partager son écran et je vais parler sur son partage.
Bon, on va à l'écran.
Can you see the screen?
Chimango, allez-y.
I should go first?
Yes, I think that's what Usman is trying to say.
Okay.
Oui, est-ce que c'est bon? Allô?
Oui, on va à l'écran là.
Ok, d'accord. Donc, attends, Chimango au début. Chimango.
Yes, Osman.
Ok.
Can I go first or you go first?
Tu peux y aller. Après, je reviens.
So Chimango, you can go first. Yes, agree that you go first, please. Go ahead. Because of
Okay,
time,
all right.
try to,
Yeah.
yes,
Thank you very much. I'll try to be brief as much as possible.
Yeah, thank you.
Yes, my name is Chimango Nyasu. I'm a PhD student registered at University of Gaston Berger. I'm working with our theatre, Stan Traore, Chekba, and Abdullahi Demi. I'm presenting on towards resilient agriculture to hostile climate change in the Sahel region. It's a case study of machine learning-based weather prediction in Senegal. So basically in this presentation, I will talk about a brief introduction, then I'll go on to the methodology, then briefly look at the results, and then finish with a conclusion. As an introduction, we all understand that agriculture is the major source of food in Africa, but also it is a major contributor of the economy at large in Africa and even worldwide. But due to climate change, agricultural production is highly affected because of a number of reasons. Some of them includes changing growing seasons, increased frequency and intensity of extreme weather events, changes in water availability, and the eruption and the spread of pests and diseases, and many others. So basically, the main objective of our study is to develop machine learning-based models which are adapted to the context of daily weather forecasting. In this case, we are looking at forecasting of rainfall, relative humidity, maximum and minimum temperature in Senegal, but also with the focus of making the predictions based on spatial weather distribution and the weather annual cycle. So the parameters we are predicting are considered as some of the important parameters for crop production. So this study was implemented using the principles from knowledge discovery in databases process, where we look at the data selection, preprocessing, transformation, feature engineering, the actual data mining, evaluation and interpretation of results. So in this study, we explored a stacked ensemble model and the 10 regressors, like random forest, decision trees, nearest neighbors, and other models. For evaluation, we used mean absolute error, mean squared error, root mean squared error, and the R squared matrix to evaluate the performance of the models. So the features which we are using, basically it's the year, month, day, relative humidity, rain, minimum temperature, and the maximum temperature, which we obtained from the NASA Power Project. The data is spanning from 1982 to 2020. For the prediction of rainfall, we used relative humidity, maximum temperature, and minimum temperature and day of the year as the predictors. But also on top of that, we did some data transformation and the feature engineering so that we could improve the correlation of these predictors and the target variable. For prediction of relative humidity, maximum temperature and minimum temperature, we are using 5 lagged values to make the prediction. Basically, this is because the autocorrelation of these features up to 5 lagged values is a bit strong for us to make a better prediction. So when we made a comparison of the regressors and the stacked ensemble model, the results shows that the ensemble model gave us the best results for all the parameters we are trying to forecast. For example, for relative humidity, we got R squared of 93%, maximum temperature 82%, minimum temperature 90%, and then rainfall 77%. But also we got the lowest values for mean absolute error, mean squared error, and root mean squared error. So in this case, the ensemble model is giving us the best results which we can use for the actual forecasting of these parameters. Yeah. So what I have in figure 1 is the for example, in figure 1A is the daily observed maximum temperature for a location in the north, in the center, and in the south, so that we can observe the spatial distribution of the weather in Senegal and look at how the machine learning is also able to make the predictions. So in this case, we expect that maximum temperature should increase from the south to the north. For example, from Koda to Matam, we should expect that the temperature should be increasing. So what we have in figure 1A is the observed temperatures. What we have in figure 1B is the forecasted maximum temperature for the same locations. So we see that the model is able to make the forecasting correctly in terms of the spatial distribution of the weather here in Senegal. In figure 2, I have the monthly average observed rainfall in figure 2A and the predicted monthly average of forecasted rainfall in figure 2B. So what we expect is that for rainfall, it should start slightly from maybe around June to October.
What I needed is that...
and then the increase is from the north to the south. So we expect the south to have more rains, and then in the center, and then in the north. So in figure 2, we also observe that the model is able to make the correct predictions in terms of rainfall also for the annual cycle. In conclusion, we observe that the models made predictions according to the spatial weather distribution and the annual weather cycle in Senegal as expected. But what is most noted is that the models struggled to correctly predict the extreme values for relative humidity, maximum temperature, and the minimum temperature. Mostly we noted that the model didn't manage to make the correct predictions for the higher peaks of, for example, temperature. The models predicted rain on some days that no rain was recorded. So in this case, the model made some false alarms of rainfall. So for our future work, the models requires further improvement so that we should be able to get the more reliable results when we make the forecasting. These results are published in these papers. Those who are interested, we can share the papers so that they can go into the detail of what we have done. Thank you very much. This marks the end of my presentation. I will leave the floor to my colleague Osman.
Yeah, thank you, Chimango. So, Usman, you can have the floor. Please make it very brief, please.
Ok,
Very,
merci.
very brief. Yeah.
Merci, monsieur le modérateur. Donc, je m'appelle Ousmane Diom, donc je suis PhD student à Gaston Berger Université. Donc, je représente le Centre d'excellence africain pour les mathématiques informatiques NTIC.
Attendez, s'il vous plaît. Sorry, I hope the interpreter is already interpreting for those that are listening in English. Please. Yeah, thank you. Yeah.
Ok, c'est bon.
Allez-y. Oui,
Ok, next, Simango. So, je vais vous présenter aujourd'hui nos travaux donc, sur le deep learning et la télédétection donc, appliqués à la surveillance environnementale. Donc, nous allons parler des problèmes, donc, puis de la méthode que nous avions utilisée et ainsi que les résultats obtenus. Donc, next. Donc, nous savons tous qu'en ce moment, nous faisons face à d'énormes problèmes environnementaux. Donc, au niveau global, nous avions les changements climatiques et au niveau local aussi, nous avions beaucoup de problèmes, donc comme les déchets clandestins. Donc, au Sénégal, simplement, chaque année, plus de 3 millions de tonnes de déchets sont produits. Donc, et une partie de ces déchets est jetée clandestinement. Donc, et la municipalité n'a pas tous les moyens de les collecter. Donc, et cela peut impacter aussi la santé des individus, des riverains. Nous avions aussi, à Dakar, nous faisons face à une augmentation des constructions de maisons. Et cela fait que, donc, il y a une mauvaise urbanisation et on manque vraiment de verdure et d'arbres. Et cela conduit à ce que, à Dakar, par exemple, il y a une mauvaise qualité de l'air. Et pendant l'inondation, par exemple, beaucoup de buildings, donc beaucoup de maisons sont sous les eaux. Maintenant, comment on peut faire pour pallier à tous ces challenges-là? Next. Donc, pour pallier à tous ces challenges-là, next, Mango. Donc, pour pallier à tous ces challenges-là, nous devions impérativement mettre en place, c'est trop. Donc, précédent. Donc, nous devions mettre en place un outil de surveillance environnementale en utilisant les techniques de deep learning et de télédétection. Donc, le deep learning, ici, nous avons le computer vision, donc qui est une partie du deep learning qui est elle-même une partie de l'intelligence artificielle. Et pour la télédétection aussi, nous allons utiliser les drones ainsi que les satellites. Donc, pour notre première étude, donc, qui concerne la détection automatique des dépôts de déchets clandestins, donc nous n'avions pas des données qui sont sur le net. Donc, nous devions collecter notre propre données. Donc, en quoi faisant, nous avions choisi plusieurs sites, donc au nord du Sénégal, c'est-à-dire à Saint-Louis, et à Tivaouane-Peulh, qui est à côté de Dakar. Donc, et nous avions choisi plusieurs types de sites. Donc, selon sur le littoral, donc à côté aussi des rivières et aussi en dessous des arbres où parfois on peut trouver des déchets. Donc, nous faisons voler le drone Mavic Pro donc à une altitude de 5-10 mètres et un angle de 90 degrés. Bon, l'avantage des drones, c'est que nous avions des images de très grande qualité. Et lorsque nous avions pris plusieurs images, donc on va faire du processing sur ces images-là. Donc, en quoi faisant, nous avions des algorithmes d'atténuation de la lumière. Et après, on prend cette image, on les divise en plusieurs petites images. Donc, ce qui nous fait une base de données qui est beaucoup plus grande. Donc, avec cette base de données-là, nous avions des images, comme vous le voyez, after processing. Donc, des images qui sont beaucoup plus nettes pour notre modèle. et on fait le labeling sur cette image-là. Next, Shimango. Donc, après avoir fait la labellisation et tout, nous avions choisi plusieurs modèles de deep learning pour voir quels sont les modèles qui sont plus adaptés à notre contexte local. Donc, il y a plusieurs familles de deep learning, hein. Donc, là, nous avions le SSD, donc, qui est l'objet de détection simple. Mais l'algorithme de l'SSD présente beaucoup de confusion. Donc, là, nous avions plusieurs faux positifs et plusieurs faux négatifs. Nous avions le masque RCNN qui ajoute aussi une branche de segmentation, c'est-à-dire un niveau de complexité de plus,
Oui.
donc qui permet de réduire les faux positifs. Donc, nous avions aussi le panoptique Deep Lab, donc qui augmente encore, donc sur le masque RCNN, un autre level de complexité. Et nous avions pu avoir une réduction de faux négatifs avec ces méthodes-là. Donc là, en grosso modo, nous avions des modèles. Donc le modèle sur le littoral et un modèle pour les déchets qui ne sont pas sur le littoral avec un score de 0,96. Next. Donc, toutes les informations que nous avions eues à partir de nos expérimentations nous ont permis de pouvoir mettre en place notre propre architecture. Et notre propre architecture nous permettra de faire la détection des buildings, la détection des arbres, la détection des végétations et aussi la détection des inondations. Donc, l'objectif final, c'est d'avoir une carte faite par notre modèle de segmentation qui pourra nous dire à cet endroit-là, il y a énormément de buildings. Donc, ce n'est pas normal. À cet endroit-là, nous avions trouvé des déchets. À cet endroit-là, il manque de verdure. Et toute cette information sera centralisée sur une plateforme que nous avions appelée Diffond Tool, donc qui est en phase finale de développement en ce moment, donc qui permettra aux autorités d'avoir toutes les informations nécessaires pour pallier à tous ces problèmes-là. Donc, lorsque les autorités auront toutes ces informations, ils pourront faire une meilleure planification parce qu'ils auront toutes les informations nécessaires pour pallier à ces différents challenges-là. Donc, ça, c'est l'objectif de cette étude et l'impact qu'il pourra avoir sur tout l'étendue du territoire national et même africain. Donc, voilà pour ma présentation. Je vous remercie. Donc, merci beaucoup pour votre attention.
Okay, thank you, Usman Achimango, for your presentation. And the last presentation was talking about using our AI to kind of do some segmentation of the area of the territory. So we're going to come back to you later on. I hope we have enough time for question and answer. I will just want the last speaker to speak now for the next maybe 9-10 minutes. Then we will ask some general questions. Then we'll have the presenters to make some comments before we leave. So I'll call on Jamido to make his presentation.
Yeah, thank you very much, Dr. Holumoyoa. So before I get started, I would like us to do just a brief exercise. If you have your smartphone here, and I am also dropping a link to the chat box. So if we can just answer this question, rank these sectors according to how much you believe they will benefit from AI in Africa. So if you click the link in the chat box, you can just rank the first, second, third that you believe will benefit the most from artificial intelligence in Africa. Yeah, you can rank as many as possible. You can rank all the 7. Okay. Nice. I can also see some people dropping their thoughts in the chat box. Okay. Jean Bosco said education. Martin said agriculture. Professor Dr. Ahmed said healthcare. John Babayemi said education. Barbara said healthcare. Nomsa said education. Esther Furigua said healthcare. Yeah, so, and that is what I think we can also see from the chart. Education is coming first. According to what Africans believe, will benefit from AI the most on the continent, followed by agriculture, and then healthcare. Yeah, I mean, that's sort of really aligned with what I think will advance human capital development and prosperity in Africa generally: education, healthcare, and agriculture. So while people are still voting on that, I will now start my presentation. So my name is Jamie Hido, and I hold a master's in artificial intelligence from University College London. I am the co-founder of Sahel AI, and what we are doing at Sahel AI is to build localized artificial intelligence that is tailored to the specific needs of African organizations. And then within the next few minutes, I'm going to talk to you about AI in Africa and also discuss briefly about my master's research, which I did on debiasing algorithms used for students for monitoring student progress. So a few weeks ago, we asked people from Africa that what are their main concerns surrounding the adoption of artificial intelligence. And the primary concern that people have about AI adoption in Africa is job displacement. And for me, I think that that clearly shows that we still have some sort of misconception about artificial intelligence, because the reality of human evolution is that whenever you have a disruptive technology, you are going to have a corresponding displacement in jobs. So the fear about job displacement, I think, is not something we should be so worried about. When Henry Ford introduced the assembly lines to factories, people lost their jobs, new jobs were created, and the world became more prosperous. The same thing happened during the advent of the internet. So the reality of human evolution is that whenever you have a disruptive technology, you're going to have a corresponding displacement in jobs. And this is where organizations, universities, governments need to come in and upskill workforce so that people can leverage the power of artificial intelligence to improve productivity. And in the end, that is what AI will do for most jobs. Artificial intelligence will be a co-pilot rather than replacing human beings drastically. So what do I think is the major issue? The major issue with AI is the potential to amplify the bias in the society. There is a recent research that said there is no computation without representation. Artificial intelligence can, if not, built well, can amplify societal bias in terms of gender bias, in terms of bias against people with disability, against people with low socioeconomic status, against the ethnic minority. So how do we ensure that we do not amplify this bias? Many times AI researchers focus more on maybe the data set. They try to see if they can balance the data set and ensure that the data set is not skewed against any group, or they focus on the process of building their models. But I see one major challenge that nobody is talking about, which is more or less a fundamental issue, is the representation of people in the computing field itself. And this is where this research is coming about. There is no computation without representation. if you look at our presentation here today, you will realize that there is only one female and all of us are male. And I think, yeah, that clearly shows a great gap. If we are going to be building models that will be used by both women and men alike, then there is a need to have due representation of the gender groups. Women must also participate in building these models. So this is the critical issue that I think we should address. And, you know, our constitutions across African countries, provided we have laws that protect vulnerable groups, laws that protect people with disabilities, that protect women, that protect everyone. So how do we then build algorithms that will amplify discrimination when there are actually laws that protect, people? There is, in Ghana, Article 17 talks about protection against discrimination. Same thing in Kenya, Article 27. Same thing in Nigeria, Chapter 4 of the Constitution. So the goal of us building algorithms is to ensure that we do not, build algorithms that will impact people negatively, the same people that have already been protected by the Constitution. A few years ago in the United Kingdom, they used algorithm to generate students' A-level scores because that year they were unable to organize A-level exams due to COVID-19 pandemic. So they just got an algorithm to just assign scores to students based on different factors. And then a lot of students came out to protest against this algorithm, against the results generated by the algorithm. Because why? They said the algorithm is giving higher marks to students from expensive schools, students from, high-cost schools in high-cost neighborhood. So that is a clear demonstration of how AI systems can actually amplify societal bias. In my master's research, I tried to then debias algorithms used for monitoring student progress. So the theme of this program today is AI in higher education. Now, universities want to know whether a student will graduate or not. Right from the beginning, the student has just entered the university and you want to know, okay, will this student graduate or not? If you know early enough whether this student will graduate, you can then provide support and intervention to support the student to make sure that, okay, since the algorithm is saying this person will not graduate, let's see how we can help them so that we can support them, and then the algorithm can change its prediction for this particular student. So what I did was first experiment was to examine the fairness of this algorithm. But in doing that, I want to understand the fairness of the data set itself, the data sources. So there are three major sources of data: the assessment data, which has to do with the scores that the student has already recorded. Maybe the student has just entered the university. What are the exams he has already done? What are the scores from that exam? And then also see the engagement data. So you have a module page where the students, watch tutorial videos, they access learning materials. So what is the level of engagement that this student has with learning data, module engagement data, a learning module? And then there is the institutional data, which sort of deals with the institutional data sets that the school itself has on the student in terms of their high school GPA before they enter the university, the gender of the students, the number of modules they are taking, the total credits, and all of that. That's the institutional data. And then I sort of use each of this data to predict the final grade, to predict whether this student will pass the course or not. And I realized that institutional data is the most biased. And this makes a lot of sense because you should not be predicting whether someone will graduate from the university using their gender or using the score they had during their high school. Engagement data has minimal bias, not as much as institutional data. Also makes sense because this has to do with, okay, whether this student is actually studying, is actually watching tutorial videos on the university module portal or something. And then assessment data as the least biased also makes a lot of sense because assessment data deals directly with the current performance of the students in the university itself. So there is a dilemma that universities will face when they try to adopt an algorithm to monitor student progress, to predict whether a student will graduate from the university or not. The dilemma is the fact that you want to get this prediction early enough so that you can quickly make your intervention. However, if you get it very early, that means you will not have enough data. For instance, if the student has just entered the university and you are immediately getting predictions, that means the student has not done any exam, so you don't have any scores. That means the student have not done any engagement with the module. You don't have any of that engagement data. What you have is just institutional data. That means you have a very poor performance in terms of the accuracy of the prediction. And then there is also the dilemma of efficient resource allocation. You want to make sure that you keep your false negative and false positive very low so that you don't end up providing intervention and support for students who don't need it. So these are the three trade-offs: the timeliness of your intervention, the accuracy of your prediction, and of course, ensuring that you efficiently allocate your resource as a university. So I developed what I call the optimal time index to balance these three trade-offs. And I realized that for a typical course that has a duration of 255 days, it is at day 60 that you'll be able to, get the optimal, time, is the optimal time to make prediction, balancing all these three trade-offs. And then at day 60, you can say, okay, let's generate a student report and see which student will graduate or not. So, like I said at the beginning, AI systems have the potential to, amplify bias. And then I try to mitigate some of these bias in the model, use data strategies in terms of putting, making sure.
Can I also summarize? Yeah, thank you. Go ahead.
Yeah, I'll quickly do that. So, and then in terms of making sure that the data is balanced and is not biased, skewed against any group, also try to see if we can penalize the model. So if a model is using gender to make prediction, penalize it so that you don't encourage bad habits, the model exhibiting bad habits. And then there is something we call counterfactual fairness, where you sort of, if the model has predicted that this person will fail, okay, but this person is a male. How about you change from male to female? That's the only thing you are changing from the data. You change that person from male to female. Will the model still predict the same thing? That's counterfactual fairness, and try to I did all of this and generate student progress card. For instance, so this is some sort of at the beginning, the Director General talked about AI used for personalized learning. And this is what I try to do here. So for each student, you want to generate a progress card. And this I did at day 60. The algorithm has predicted that this student will fail. Now, to increase the explainability so that the teacher can really know, okay, how is the algorithm making decision? What is the probability that this student will fail? 66%, 0.66. And what are the things this algorithm is using for prediction? This algorithm is using the interaction of the student with the module page, the score of the student, the total studied credits. And then here I did counterfactual fairness. I flipped the gender and tried to see if the prediction will change. It doesn't change, which means it is fair counterfactually. And then also validates the fairness and all of that. So yeah, that was my research. And after that, after my master's program, I am now building an AI company where we are building localized solutions for African organizations. And if you want to reach out to me, you can just send me an email at hello@sahel.ai. Thank you very much.
Thank you so much, Jamil. I think you helped to answer some of the questions people have been asking. So I think that was good to have you rounding up the presentation. So far people have presented different things. And the objective for today, as was presented also by the Secretary General, to showcase AI-related research and what students are doing in the field of AI. And to sensitize students, whether PG or undergrad students, about the responsibilities of AI and to promote AI awareness among African students. And I think that has been properly addressed in the presentations. We've seen people using AI in agriculture, we've seen it in climate, in the presentations we've had, we've seen it being applied to language as well, solving language problems, and to health as well. And so that is also very interesting to see. And not only that, I could gauge the presentation. I saw some are postgraduate students, some are undergrads, and that also makes sense to see that at both levels we are making progress trying to develop. Now, my question would be, just in the next 2-3 minutes we have, and anybody that can speak among the presenters will be, all this we've done or we are doing, how do you mainstream? It's good to do research, but if our research ends up on the shelf, that will still not help us to develop. How will this come to market and can be things that people, Africans, can use? More importantly, that we have been complaining that there's bias in the data coming from the West and whatever. If we are building, and I can see that some of us are also creating data, so what will it take us? What are the challenges we're facing? What will it take for us to now get those things out and we'll start using it to solve our problems? So 1 or 2 responses before we close. Who wants to go first? If you have questions, you can type in the chat box. I see that the speakers have been attending to questions. That's why I'm not going to read out all the questions because of time. And if you have comments, also you can put it in the chat box, can read it out. But to these questions, the question I gave now, anybody among the speakers that want to address the challenges or what it's going to take to get this thing mainstream and become, things, applications that can be used. Martin, okay. Martin, you're not the speaker, but at the same time, okay, Ayomide wants to say something. Ayomide, you can unmute yourself and go ahead.
Okay, thank you, Prof. I'm Professor Martin Jumochua, and I'm
hold on. Prof is talking.
Deputy Vice Chancellor for University in Mozambique, UNICEF.
Welcome, Prof.
All right. First, I would like to congratulate the students for the excellent job they are all doing. And as we all know, AI is no longer in the sphere of the academia. It has now entered into the domain of national politics and policies, especially security policies for some nations. My advice to them is, do not let whatever is being debated stop you from what you are doing, you, the young generation. Continue to do what you are doing. Focus on problems relating to Africa so that we can solve our problems. Because people think AI is going to replace humans, but that is absolutely not true, because Albert Einstein once said, computers are incredibly fast but stupid. Humans are intelligent but slow. So there's no way AI is going to replace humans. So focus on your research in areas that will benefit Africa, and it will help the continent to move forward. Thank you.
Thank you so much, Prof, for that comment. Thank you. So Prof is encouraging us that we should continue to develop, not just listening to all the complaints about AI taking over. I think we should need to continue to develop, and more importantly, our own data that can reduce the bias. So that, most of the time we use data curated or generated as well. And I think it's high time, maybe through the leadership of AAU, that we need to begin to push our government as well to invest in data set curation and generation. Most of the even funding that comes around for data set generation, they come from outside the country. So we need, as Africans, we need to begin to invest in that so that we can generate our own data and make progress and be able to build systems that take into consideration our own context, not just the Western context. Okay, Ayomide, you have, maybe before I allow Ayomide to talk, do we have permission? Because normally this session should end by 12 GMT. Can we extend by 10 minutes? Do you have that permission? Madam MC, do you give us permission, or should we just end another 1 or 2 minutes?
You've got 10 minutes, so let's end in 10 minutes, please. Thank you.
So you giving us permission? I didn't get that very well.
Yes.
Oh, okay. Thank you so much. Thank you so much. So Ayomide, you have the floor. You can just make a contribution.
Thank you so much, everyone. Thank you for the opportunity. So from my end, I believe that schools, higher institutions are closer to the government than individuals, and students have like a lot of innovative ideas, but the major thing is support. And I believe that if higher institutions can, have like lot of hubs, and I know that for example now in Unilag we have society like Google Developers Students Club, we have DSN Data Science Nigeria, and we have a lot of private organization. But if we can have like government organization whereby this organization connects students even to investors, because investors trust those organizations, those ideas that are closely or they are connected to government. If I'm an investor now, I'll probably buy into the idea of someone that is with the government and someone that is just coming as an individual. So if you can have such organization or such let's say an org in university to be very, very okay, because for me as an example, like I have teammates and classmates or classmates that have a lot of ideas, beautiful ideas. We built something, but then we can't sell it out because of probably searching for investors, searching for a fund is
Okay.
nice.
I think I can get you platforms that can allow university researchers, maybe students, maybe lecturers to be able to showcase what they are doing and get support so that they can kind of take it further. Okay, that's fine. And I believe the secretariat is also taking notes, and we'll begin to see the intervention. Okay, I'm seeing two hands raised. Obafemi Kenshiro, can you make it just a minute? Your intervention a minute. Obafemi Kenshiro, please. I've asked you to unmute. If you still want to speak. Okay. Paul Omaji, I can see your hand. Let me hear you too. Paul?
Yes, can you hear me?
I can hear you very much.
First, I need to.
Oh,
wonderful. Look.
Okay, Paul, hold on, Paul. Let Obafemi Kenshiro give his contribution. Yeah. Okay.
So do I still have the floor?
You have the floor, but please make it as brief as possible. Less than a minute. Go ahead, please.
That was quite poor. I don't know. It would be nice if we can get the slides shared. I don't know through what medium we can have that. I would really appreciate, especially.
Okay, it's like the network is breaking, but what I heard is that you would like us to share the slide. So I think that should be possible since you registered to join. So we have the email address of everybody, and that should be possible. Okay, so can we move to Paul? Paul?
Hello, can you hear me?
Yes, Paul, I can hear you. Please go ahead.
Wonderful. Look, I want to celebrate the AAU for this program they've put together, and listening to the presentations today, I'm quite excited because it's like a very powerful way of demystifying AI. When you are beginning to talk about the application of machine learning to real world, or real life problems, like in the area of agriculture, I think I want to encourage our young, intellectuals to pursue these areas of using AI to bring about solutions to the issues that confront Africa as a continent. I think the point is being made that no matter how sophisticated AI becomes, it can never replace humanity. Rather, it will contribute to the prosperity of humanity, especially on the African continent. So I just want to lend my voice to those that are encouraging and challenging our young ones to pursue this area of development, and indeed get to the forefront of leading the rest of the world in the application of AI to problems that are unique to Africa, so that we can have a better continent. Congratulations to AAU and congratulations to our young academy.
Thank you so much, Paul.
Vice Chancellor Admiralty.
Thank you so much.
Okay.
Yeah, thank you. So we have Yogesh also raising his hand. You can go ahead, please.
Thank you, Dr. Victor.
And I've been seeing your questions. That's good. Thank you for the questions we're putting on the chat box. Thank you so much.
Thank you very much. Only one comment at this moment I would like to share with all the researchers, because as we know that people have a myth that artificial intelligence is a challenge, but still there are so many challenges, because maybe AI is only beneficiary for the rich people or rich agriculture. But what is as a technocrat, as a technology specialist, it is our responsibility that these facilities must be reaching to the last person of the society. Do you think that these robotics, drone, this pattern recognition is benefited for the poor people? They don't trust. Believe me, they don't trust on these results. They work on their experiences. So this is our responsibility as a technocrat, as a researcher, to send our research in the public domain so that they can trust. So that was the thing which I want to share with all of you. But thank you very much.
Thank you so much, Yogesh. I mean, yeah, what is very relevant. How can we kind of? It's like you are saying that AI is also kind of making the divide to be wider, making it wider, because some that are rich, they are more empowered. And those that have technology are more empowered, while the other ones are not coming close. And there's like, yeah, so I understand that. So how do we, if somebody does not have a smartphone, it does not even have internet, how can it benefit from AI? And the majority of the people, the agriculturists, that's the category we fall into. So I understand that question. Of course, this 2-hour session is not enough to really kind of handle this, this important area of AI and the aspect of responsibility, being a responsible AI, or talking about the bias and talking about how to kind of minimize this divide. The time we have is not enough. I believe that AAU is seeing this, and maybe have subsequent sessions in the nearest future where we can also talk more about all of this and see an agenda, an African-wide agenda that can help us to kind of grow and mainstream this. So before we leave, I would like to see if we have any questions from the audience, the physical audience in Ghana. Is there anybody else to ask questions from the audience? MC, can I also check up? There is a nice suggestion here from, let me check the chat box again, just drop down. Yeah, Professor Matu said, I would like to suggest that AAU consider setting up regional AI chapters. That's interesting. So that's over to the Secretariat. Yeah, that's a good suggestion there. So any question from the physical participants?
Yes, there's one question, Dr. Odumoyiwa.
Okay, please go
ahead. Very much, Madam MC. Yes, so far, if you look at the presentations that we've had for this morning, I get a sense that the emphasis is on supervised machine learning or supervised classification, the broad spectrum. And then we are also tilting towards weak AI rather than strong AI. Do you have some comments on that? Thank you.
Yeah, I have comments, and maybe one or two speakers may have comments. Yes, of course. It's still about the issue of data. If you are doing what do you call it, supervised learning, you must have your data set and also have them labeled. And if you look at the world, not all data is collected, number one, and labeling is another big task when you're labeling. So I think we need to invest more into that kind of weak supervision, semi-supervised learning, and not supervised learning. We need to invest more. The problem is most often is about data. Yeah, the kind of data you have, and not all problems can be classification problems. So, but I don't want to go in depth into the core ML concepts because not all participants here are kind of deep in that. So, but I think what you've said is correct. We need to begin to learn more and invest more on that aspect of AI, other aspect of machine learning, so that I can be able to really address our real life problem. Even in a situation where we don't even have data. And that's one of the things that the large language model is bringing on board, the like of OpenAI large language model or the Facebook, where you can bring your problem. They have pre-trained their models, and you can actually fine-tune your own little data you have and can still be able to use technology. And can bring a problem even without seeing your problem before. Generative AIs can still be able to kind of bring in some things that can be helpful, even though at times they may be generating errors or wrong things. So, but I think these are things we need. In fact, I think we need to even do more in generative AI in Africa so that we can be able to take advantage of this. But yeah, so we have less than 1 or 2 minutes more. So I wouldn't know if there's still any question or comment as we conclude.
No, I think we are done.
Oh, that's very good. And I can see. So
because we are 12:15.
Okay.
So I think we've overstayed.
Yeah, that's disappointing.
Yeah. So I wanted to thank you, Dr. Victor Odumuyiwa, for that excellent moderation.
Thank you.
And we also thank each of the teams of the students from Kwame Nkrumah University of Science and Technology, University of Lagos, Strathmore University, Gashberger in Senegal. And also we thank Mr. Ido Jamiu for his excellent presentation. Most importantly, we thank our online guests, because I think we had about 220 people connected online. Thank you very much. Here in Accra, we recognize the delegation from All Africa Students Union. We recognize Professor Stanley Ogun from Nigeria, who came in person. We recognize students from Knutsford University College and also students from UPSA, students and faculty from Academic City University College. So thank you very much. Last but not least, we would like to remind you that tomorrow we have another event. We are featuring a forum for African vice chancellors. African vice chancellors, and we'll be focusing on AI governance and also looking at a landscape study for AI in Africa. This event will start at 12 noon GMT, not at the same time as today. It will start slightly later. But here in Accra, we are also hosting registrars from African universities. There's a professional development activity that will go on from tomorrow up to Wednesday. So thank you very much. Please keep on joining. There's a lot of exciting conversations on AI this week. Thank you very much. See you tomorrow.
Thank you, Madam MC. Can we take a picture before we leave, Madam MC? If people can put on their screen and we'll just take snap. Yeah.
Yes. Can we put on our cameras, those that are online, and can the technical people help us with a picture? But of course, there are many pages because there's a huge crowd. There's about 8 pages. Thank you.
Okay. So we'll be counting for the technical team to take the picture. So from 1 to 10, so maybe when you count 1, they will take the first screen, then count 2, take second. So let's start 1. Then we can go to 2 now. So 2. So they can take the second page.
3.
So 3.
3.
Can go to 3. Just give them time to take it before we go to 3. So, okay, if 3 is taken, they can go to 4. 4. If 4 is taken, they can go to 5. If 5 is taken, we can go to 6. And then we can go to 7. Thank you so much. Over to you, Madam MC. Thank you.
Thank you very much. I think we are done for today, and we look forward to connecting tomorrow. Okay. So just some quick announcement for our physical participants. For our guests who came from various universities and institutions, we have some small refreshments for you.